All right, let's go ahead and recap some of the basic antiderivatives from last time. So remember, the antiderivative of a function is a thing that when you differentiate it, you get back to where you started. So for example, the antiderivative of a constant with respect to x is just k times x plus some constant of integration c, because when I differentiate kx plus c with respect to x, I get k. The antiderivative of the power function, x to the n, as long as n is not equal to -1. That thing is x to the n plus 1 over n plus 1, because if I differentiate x to the n plus 1 over n plus 1 plus c, right, you bring the n plus 1 down in front, the n plus 1's cancel, and then you're left with x to the n. So these 10 things are, I would say, the basic antiderivatives that you need to memorize. The one up here, in case you can't see it, the antiderivative of secant squared x dx is tangent of x plus c, because when I differentiate tangent of x, I get secant squared. So I would say it's worth memorizing these 10 antiderivatives, and I'll make sure to get them to you in Blackboard. Let's let capital F be an antiderivative of lowercase f. So in other words, to say that capital F is an antiderivative of lowercase f, we really just mean that the derivative of capital F is lowercase f. So then the antiderivative of this composition times g prime, so the antiderivative of f of g of x times g prime with respect to x, is just capital F with g of x plugged in and then add a constant of integration c. So this is exactly the chain rule, right? Antiderivative this way means derivative this way. So if I take the derivative of this thing, right, it's the derivative of the outside function, so capital F prime, that's lowercase f, and then recopy the inside function, so that's g of x, and then tack on the derivative of the inside function, so g prime of x. So when we carry out this u-substitution, it's exactly the reverse of the chain rule. So that's going to be the goal here, is to take an antiderivative that looks like this, and then just reduce it down to one of the simpler forms from the previous board, one of those 10 basic antiderivatives. There are some other basic ones too, but those 10 I think are worth memorizing. Anyway, that's the goal, to reduce this complicated antiderivative down to a much simpler one. All right, here's the process you're going to carry out in order to reduce one of these antiderivatives down to a simpler form. And so the key is to look at the function g of x along with its derivative. So g of x and g prime of x, there's two parts present here. One of them is the derivative of the other. So I'm going to let u equal g of x. So that's step number one. So u is equal to g of x. And then I'm going to symbolically differentiate both sides, basically take the differential of both sides. So du is equal to g prime of x dx. And then the next thing I'm going to do is solve for dx. So I'm just going to divide both sides by g prime. So now du over g prime of x is equal to dx. So now here are the things that I'm going to use in order to make this substitution. So now what does this integral look like? So it's the integral of f of g of x, g prime of x, dx. Now that's equal to what? So we know that u is equal to g of x, so instead of writing g of x, I'm going to write u. So this is the integral f of u, and then I'm going to just copy down g prime of x, and then what's dx? So it's du over g prime, And so now the g primes will cancel, and you're just left with the antiderivative of f of u du. So now that you've reduced this thing to a simpler form, we know what the antiderivative of this simpler function is. It's just capital F. So now I know that this thing is equal to capital F of u plus c. What is u really equal to? Well, it's equal to g of x, so I want to write my answer in terms of x, in terms of the original variable. So this is f of g of x plus c. And that's what we expected to get, right? We know the derivative of this thing is equal to this thing by the chain rule. So this is the program I'm going to carry out every single time. The only hard part to these problems really is to try to identify what u should be equal to.